It's perfect.
Just gives information. And I really like this. I don't know what kind of machine it is, but it's very cool looking.
This is the thermal evaporation.
What is
Yeah,
it?
this is the thermal evaporation. We use it to evaporate the gold and the solar cells as a cathode contact. Yes.
It's cool.
So this is gold actually inside?
Yeah, the gold is in a boot, and what I take it by my hand. It's the substrate sample. I put the substrate sample, then I close the door, and I use the computer to process the evaporation for the gold.
Wow, crazy.
Good afternoon and good morning and welcome, everyone. Thank you for joining us for the IBK webinar, Innovations in Energy and Avenues for Engagement. My name's Dorothy Hanna. I'm the Program Administrator for the CAXT MIT Ibn Khaldun Fellowship for Saudi Arabian Women. Today, our panelists will discuss their own contributions in the field of energy and where we go from here. After their discussion, they will answer questions from the audience. Please put your questions in the Q&A section as we go along, and we will answer all of the questions at the end. First, I'd like to welcome Professor Kamal Yusuf Toomey. He's a professor of mechanical engineering at MIT, and he is the director of the Ibn Khaldun Fellowship for Saudi Arabian Women. So, Professor Kamal, please give us a little more information about the IBK Fellowship.
Yeah, hello everyone. I welcome each one of you to this important webinar series. The Ibn Khaldun Fellowship Program was created maybe 12 years ago or so. And this is specifically for the Saudi Arabian woman. I had mentioned before that this was part of a program that we had with King Fahd University of Petroleum and Mineral program that we had in water and energy. And at that time, the university had only men in it, and MIT required that we had to create a special program for Saudi women, and this is how the Ibn Khaldun program, came about. I am very happy to be or part of this seminar webinar series, and also welcoming our distinguished panelists, Dr. Fatimah, Dr. Malak, Dr. Nouf, and Dr. Thamraa. And the panel is about innovation and energy. And as you know, the innovation is very, very important because behind it there is the research that drives the innovation. The innovation drives the long-term economic growth. And with these innovations and growth, that the nations and the economies in the world, compete, and they compete based on innovation. So this is a very important aspect. And energy is the base, for everything that we do, right? And so I look forward to listening to to our panelists, and shukran lakum, barakallahu feekum. Thank you.
Thank you, Kamal, and thank you to our panelists. And I'd like to invite our panelists to introduce themselves in alphabetical order. Dr. Fatimah, would you begin by introducing yourself today?
Good morning, everyone, and good afternoon. It is a pleasure to be with you today. My name is Fatimah Edhaim. I've been working at Aramco since 2007 as a lab scientist. I've led several projects in different fields like upstream, downstream technology and research projects. In 2007, I've graduated from King Abdullah University of Science and Technology in chemistry. I was working in synthesis and characterization of methyl chalcogenide aerogel, which is a type of porous material for gas and volatile hydrocarbon separation. Currently, I am a postdoc at MIT working in a porous material called the zeolitic imidazolate framework that's also used for gas separation. That's it.
Thank you so much for joining us today.
Thank you.
Dr. Malak, would you introduce yourself next?
Sure. Thank you, Dorothy. Thank you, Dr. Kamal, for the introduction for the program. This is Malak AlNory. I am Associate Professor at the College of Engineering in Ibk University. I'm also Provost of Ibk University, responsible of all our academic affairs. I'm very proud to be the first Ibn Khaldun Fellow. That was back in 2012, end of 2012. Since then, I continued my relationship with the program. I received a huge amount of support from Dr. Kamal, from Dr. Professor John Lienhardt, from Teresa, and from everyone until today. My research is focused on early at the beginnings on desalination and optimization of desalination processes in consideration of environmental impact and economic impact issues as well. This was extended later on to look at the energy because we cannot do desalination without looking at the energy source. And then I started to look at the different sources of energy, and I studied the use of renewable energy into desalination, and how can we produce solutions that are innovative and sustainable to support both the demand of water and demand of energy while not harming the environment and minimizing the environmental impact. Thank you.
We're really glad to have you with us today. Thank you. Dr. Nouf, will you introduce yourself, please?
Sure. So assalamu alaikum everyone. I'm Nouf AlMousa. I'm a current Ibn Khaldun Fellow and an Assistant Professor of Nuclear Engineering at Princess Noor University, and currently a research scholar with the Department of Nuclear Science and Engineering at MIT. My research basically includes plasma physics and plasma material interactions in nuclear fusion reactors. Also, I'm passionate about investigating the effect of extreme environments in nuclear systems. And by extreme, I mean high pressure, high temperature, and high radiation, and also highly corrosive nuclear environment, and how these environments affect nuclear reactor components, maybe in a bad way or surprisingly sometimes in a good way as well. I have some research expertise on storing spent nuclear fuel for the better of our environment as well. So basically, I'm passionate in anything nuclear, in between splitting an atom for a fission reactor or fusing two atoms for a fusion reactor, and until the fuel is totally spent and ready to be disposed, and anything nuclear in between. And I'm glad to be part of this webinar as well. Thank you so much, everyone.
We really appreciate you taking the time to be with us today as well. Dr. Thamraa, will you introduce yourself?
Assalamu alaikum everyone. I am Thamraa AlShahrani, an assistant professor in physics department, Princess Noor University. I am a solar energy specialist focusing to improve the solar cells efficiency and stability. As a scientist also, I am applying project management and leadership strategy in the project to gain both the solution and best practice. My postdoctoral research in BF lab at MIT in Boston between 2017 and 2018. I conduct research with the MIT BF lab groups, joined with the Aramco, and the topic relating to my country, which is the perovskite tandem solar cells for hot and arid climates. And the result was presented in MRS Spring Conference in Arizona. And also the MIT News also wrote about this research on the website. My PhD was from Bangor University, United Kingdom in 2016, solar cells. Also the master degree, I did it in nanotechnology and microfabrication in 2010. Also last summer, not in 2019 summer, I am a visiting researcher in Civil Structure and Environmental Engineering Department at Trinity College of Dublin. My research interest areas include, but not limited to, the photovoltaics, LLD, transistor, energy storage, hydrogen fuel cells, semiconductor materials, and nanomaterials. I published several articles in peer-reviewed journals related to the solar energy application, and also I participated in several conferences and committee relating to the solar energy. Thank you.
Thank you so much for joining us today as well. And I'm really looking forward to hearing from such a wide range of perspectives on energy. So to get us started, Dr. Fatimah, will you tell us, what does innovation look like in your field of energy? And go ahead. We hear you now. Yeah.
Okay.
Can we see the slide?
Just a minute. Okay. So good morning and good afternoon, everyone. Today I'm going to explain and show you some information related to the membrane material entitled Membranes as Energy Efficient Technologies for Gas Separation. During the presentation, I'm going to give you a brief introduction and motivation for membrane-based separation. I'm going to talk about membrane structures. After that, I'll explain the membrane separation mechanism. And then I'm going to talk about the future market of membrane technology. And finally, I'll conclude the presentation with the acknowledgements. So let's move into the first part of the presentation, which is the introduction. In fact, the main sources of the air pollution are the industrial processes, with around 58% of the CO2 and volatile hydrocarbon that emitted every year. While consumer solvent can cause around 5% of the air pollution, motors and vehicles could cause around 37%. So the extensive use and the production of volatile hydrocarbon and CO2 would make the minimization of these killer gases so challenges or so difficult. Therefore, they consider as a major air pollution. Furthermore, the volatile hydrocarbon possess low boiling point and high vapor pressure, so they can evaporate easily and contaminate our environment. Furthermore, both CO2 and volatile hydrocarbon can accelerate the global warming, which we can feel it by the shrinking of the ice, heating of the ocean, and changing of the weather. Also, it has been recorded that around 7 million deaths are recorded to the exposure to the air pollution. So it is essential to deal with this problem and try to reduce the air pollution. In fact, there are different strategies have been developed for effective removal and separation of these gases, like distillation, drying, evaporation, and etc. And as you can see here, membrane-based separation can consume lower energy comparing to the high energy that consumed by distillation process. In 2016, the total US energy consumption was around 97 from 4 different sectors. However, from the industrial sectors, up to 55% energy was consumed by separation process. Out of this percent, around 49% of the energy was consumed by distillation process. So distillation process is energy intensive and thermal driven process. Therefore, we have to find an alternative. One of the alternatives that had been developed is membrane-based separation, and it has been confirmed that using membrane for separation system would save around 90% of the energy comparing to the distillation process. So using membrane material can save around 100 million tons of greenhouse emission and around $4 billion in energy costs annually. Furthermore, using membrane material for adsorption process like zeolite material, metal organic framework, covalent organic framework, polymers, and molecular sieve can enhance the separation efficiency up to 90%. Furthermore, these materials require the smaller space comparing to other systems, as you can see here. So the space required for membrane material and the other systems require larger space. Also, membrane material can separate both organic and inorganic substances. So what are membrane materials? fact, membrane material can be porous membrane or dense membrane materials, and they act like filters. So the small molecular size can enter the pore system and get separated, while the larger molecular size would be prevented from entering the membrane material. However, for dense membrane, the solubility and diffusivity of the gas will play the role. The performance of membrane material depends on the permeability and the solubility, while the permeability is the ability of membrane material to allow the permeating gas to pass it through, and it depends on the diffusivity and the selectivity, solubility of the gas itself. We can measure membrane material based on the membrane thickness, area, and the pressure differences across the membrane material and the permeate flow rate. The selectivity is the ratio of permeability of two gases in a binary gas system. However, it has been confirmed that the membrane material that has higher permeability would have lower selectivity and vice versa. And this is called the trade-off relationship. And this is like a problem of membrane material. In membrane structures, there are three types of membrane, which are porous membrane, nanoporous membrane, and carrier membranes. For porous membrane, the selectivity depends on the pore size, and here is a real example of porous membrane material. Furthermore, based on Ibk, the porous material can be categorized into three categories based on their pore size. And these categories are microporous material, which possesses pore less than 2 nanometer, mesoporous material, which possesses pore in between 2 and 15 nanometer, and microporous material, which possesses larger pore size, which is larger than 15 nanometer. Porous material could be used for microfiltration and ultrafiltration. Non-porous membrane is a dense material, and the polymer is a good example of non-porous membrane, and the separation in this case depends on the solubility and diffusivity of a specific gas. So these materials are usually used for gas separation. Carrier membrane material. And this material, there are some carrier molecules that have been added to the surface of the membrane material. So this carrier has the affinity toward the specific gas. So this material possesses high selectivity, and can be used for gas and liquid separation. For the mechanism, membrane separation, there are 4 mechanisms, and the first one is size sieving, is the most common mechanism that have been used to separate the gas flow. However, in this case, the membrane material is porous material, and the pore size is just in between the small molecular gas and larger molecular gas molecules. So in this case, only the small gas molecules will be allowed to freely enter the pore system and get separated. However, the counterpart gas molecules will be prevented from entering the pore system. Surface diffusion mechanism, in this case, the membrane material has the affinity toward a specific gas. So the more affinitive gas will get absorbed on the surface of the membrane material and move along the pore walls until it gets separated. However, the less absorbable gas molecules will have low probability to enter the pore system and get separated. Solution diffusion mechanism, in this case, the membrane material are dense material, and there are no pores that facilitate the gas transport. So in this case, the separation of the gas depends on the solubility and diffusivity of the gas. So the more soluble gas will dissolve and absorbed by membrane material at the feed interface, and due to the higher pressure at the feed interface, the gas molecule will diffuse through or across the membrane material until it reaches the permeate interface. At permeate interface, the pressure is low, so the gas will desorb in this case. However, solution diffusion mechanism usually associate with low permeative flow due to the low solubility and diffusivity of the gas molecules. Therefore, facilitated transport mechanism has been developed. developed. In this case, the membrane material has some carrier molecules that can be added during the synthesis or post-synthetic modification of the membrane material. And these carrier molecules will facilitate the permeability of the more soluble gas. So in this case, the carrier molecules will attach to the more soluble gas molecules, and due to the higher pressure at feed interface, this material would diffuse across the membrane material until it reaches the permeate interface. Due to the low pressure at permeate interface, reverse reaction can occur and the gas molecules will desorb, while carrier molecule can go back to the feed interface in order to attach and deliver another gas molecules. In fact, there are a huge number of membrane material, and generally we can divide them to polymer membrane and nanoporous membrane. For polymer membrane is the most common option that can be used in chemical and petrochemical industries for CO2 separation from the gas flow. Also, polymer membranes is a good example for solution diffusion mechanism. So the more soluble gas will dissolve in the small holes that appeared in the surface of the polymers and then transfer from hole to another until it gets dissolved. The main problem or drawback of polymer is the trade-off relationship. So the material or polymer that has lower permeability would have high selectivity. Therefore, most scientists, in order to increase the permeability of polymer, they use the carrier molecules, or they use different type of polymers, which we can call it glassy polymers. This glassy polymer can change its mechanical properties during the adsorption process. Nanoporous membrane also is a huge materials. I mean, there are varieties of these material, and here I'm going to give you only 4 examples. The first example is silica membrane or silica oxide membrane, and this material are mesoporous material with high porosity. So this material have high porosity, have high permeability and low selectivity. So in order to increase the selectivity of this material, amino functional group can be added to the surface of the material and make the surface or increase the roughness of the surface in order to increase the selectivity of this material. However, the main drawback of this material is the cost that associate with the scale up of this material. Therefore, a new method has been developed, which is producing the silica particle inside the polymer's membrane in order to increase the selectivity and reduce the cost. The second example is zeolite material. Zeolite material is aluminosilicate crystalline material, and this type of material attracts the attention due to the high selectivity of this material that depends on the pore structure or pore size and the polarity of this material. The third example is metal organic framework. This is a unique crystalline microporous inorganic organic hybrid material. This material possesses high separation efficiency, possesses high storage capacity and high selectivity. However, the main drawback of this material is the stability, water stability. Therefore, a subclass of this material has been developed, which we call it zeolitic imidazolate framework. This material possesses or inherit the separation properties from metal organic framework and inherit the thermal and air stabilities from zeolite material. For the membrane separation technology market, it is anticipated that the market of using membrane technology will increase or will grow during the next 5 years, and this is because of increasing application in water and wastewater, growing demand from food, and the growing of the industrial applications. And based on ongoing studies that started in 2016, the Asia Pacific will dominate the market across the membrane material due to the consumption from the countries like China, India, and Japan. At the end, I'd like to thank IBK, specifically Dorothy Hanna, Nadia Shahid, Riza Wirth, and Professor Kamal Youssef for their usual support and help. I'd like also to thank CAXT, Saudi Aramco MIT Energy Initiative, for giving me this opportunity to work at MIT. Thank you.
Thank you so much, Fatima, for that very thorough answer. And I want to say that some of our panelists, I think, prepared more a presentation style and some more a question and answer style. So Dr. Malak, I think you had maybe a shorter answer prepared. And I'll ask you the same question. What does innovation look like in your field?
Okay, thank you, Dorothy. I define innovators, people who find solutions to achieve intended objectives in the best way. So an energy for a solution to be innovative, it is not enough for it to be just new, because sometimes people think of innovation just bringing something new to the field, and this is innovation. It's not enough to be new. Innovation in energy is beyond the choice of a new technology or introducing new technology or substituting an existing one with a new one. It should actually brings in transformation in the energy system. In essence, providing sustainable supply and use of the energy that meets the needs and the demand of our planet, of humanity, is the successful development and delivery of innovative solutions. Sustainable solutions means that they have to tackle 3 areas. It has to be economically sustainable, means that it's cost effective, it provides, it is viable in whatever it is, there is a problem and this needs to be the solution in this problem. Socially, so it should brings in value to the people, to the human, should introduce another aspect of well-being to the people. And ecologically, which is environmentally effective, does not harm the environment, does not worsen the issues of climate change. Just like Dr. Fatima mentioned in her presentation, these are areas that we all of us in the energy field will look at these elements in order to validate and check what kind of solutions we're providing. This means that an innovative and transformative solution should tackle the infrastructure, the policy, the technology, the business model, the infrastructure, all together in order to be included as in the range of innovative solutions. From my side and my contribution, I was recently, alhamdulillah, got the appointment as Mission Innovation Champion, which is for Saudi Arabia, which is a program by Clean Energy Ministerial that reward or recognize innovators in the field by appointing a person or an innovator for each country of the 22 countries in the Clean Energy Ministerial. And my research idea, or my idea that I proposed in order to get this appointment, is that looking into innovative solutions at the intersection between water and energy to solve the problems of the increasing demand of both water and energy. I don't want to take it this long, but I can explain, unless you want me to go on and explain what exactly my research area. If you allow me.
Please go ahead.
Okay, so specifically my research focused on using water desalination, using renewable energy rather than traditional energy-intensive resources. Also such as PV, solar, also using hydrogen production from water and using water storage for instead of energy storage, such as batteries. Technically, this can happen using optimal scheduling of operations, and this mechanism can enable cost-effective and low-carbon emissions solutions to realize higher levels of renewable energy integration into the energy grid, into the power grid, and increase the renewable energy production in the energy mix, and achieve major aspects of the circular economy. Why this is important, kind of solutions important, because it brings in addressing an issue of the high intensity of energy usage in the desalination. Today, desalination capacity in the world is 107 million cubic meter per day. Okay, so which means that the minimum energy required in order to produce this amount of fresh water to cover the demand at a large scale, even using the best technology available to us today, this means about 428,000 megawatts of per day of electricity or of electricity, which will result in 190,000, more than 190,000 tons per day of CO2 emissions. So in order to produce fresh water, even using best technology, even using best technology available, and minimum energy required, will still go to produce this amount of CO2, huge amounts of CO2. If we go the traditional way, continuing with this, then the integration of renewable energy into the power grid, it increases the complexity of the power. We want to increase our portfolio of different renewable energy, but it's not random. It's not the power grid will have to accommodate all the variability that comes from the energy, the renewable energy. Also, the cost of desalination, if we switch to renewable desalination, it will increase because it's not just membrane anymore plugged to the grid. It's also additional components of the system, which means that this is a higher cost. Specifically, that you also need to add energy storage. Energy storage still up until today, still expensive economically and environmentally. So what do we do with batteries after we were done with them? What do we do with PV modules after they're not efficient anymore? So this creates these issues. The main proposal or idea is that we can use water storage, so utilize the desalination capacity water storage in order to provide electricity when needed, so that by optimal operation of the systems, then we can accommodate the energy, the variability of the renewable energy, and we can store energy and produce it as needed.
Thank you, Dr. Thank you. And congratulations on the new position. It's very exciting.
Thank you so much.
Dr. Nouf, will you share with us what innovation looks like in the nuclear energy field?
Sure. So I want to first congratulate Dr. Malak for the new position. We're really proud of her. So innovation in nuclear is really, I'm really sad to say it, but it's going relatively slow comparing to other fields. And indeed, there is a strong need to accelerate innovation in nuclear energy. So innovation, it's no question, we really need innovation in nuclear energy. And here I mean innovation at both technical and institutional levels. The question here, what innovation will be the most influential in expanding the global market for the nuclear energy? So the institutional innovation is kind of out of our hands as an individual scientist and engineer. But I thought I should give some credit for institutional innovation to be part of the answer for the big energy challenge. I'm sure we all remember the most striking lesson of Fukushima, is that what might otherwise have been serious but a manageable kind of accident was transformed into a real disaster by multiple failures of the governance. And what's needed to correct this kind of failure is really understood now. It includes transparent decision-making process, independent regulatory bodies, and the need to build a sustained and safety culture in the nuclear operation system. So, however, as I said, as we are an individual scientists and engineers, we belong more to the land where avenues for technical innovations can be found. And this is where we can contribute greatly. So technical innovations and nuclear basically will be more important, partly because they will reduce the burden on nuclear institutions and the decision makers as well. And they will also pave the way for institutional innovations. So one of the keys to improve economic competitiveness of nuclear power will be to reduce cycle time, for example, in the nuclear industry, which include also opportunities for technically driven cycle time reductions. Another innovation phase can go to the design of the nuclear reactor. So making the nuclear reactor setting easier, for example, we have the gas cooled and the new generation of molten salt cooled reactor that required far less water to be cooled, and they even can be cooled by air. So this allows them to be easily set in any inland region. I would say also another phase of innovation can look like longer term possibilities, which includes lifetime fueling for reactor cores, which is represented by the concept of nuclear battery. So in which the nuclear battery, the fuel charged to the core at the start of the operation and would not need to be removed until the end of the life of the reactor. Also, some reactors can be even optimized to burn their own nuclear waste, which this way the innovation can allow transmuting the long life isotopes, which are highly radioactive in the waste, into a short life species. And hence this can reduce radiation hazards to the environment and to the radiation worker as well. Another venue of innovation involves materials and fuels, which focus on microstructural and thermal, mechanical, and all the material properties of irradiated nuclear fuel or nuclear material, the structural material in the nuclear system. So by studying these, by improving the response of these materials to the extreme nuclear environment, which include high temperature, high pressure, and the highly corrosive medium, and also the highly radiation environment, this can prolong the lifetime of reactor components and hence increase the productivity and short the need for maintenance or shutdown for the nuclear reactor. So all these phases of innovations are devoted towards enabling nuclear energy to play a harder role or a greater role in creating sustainable global energy supply, and even more to do better in leveling the carbon dioxide level. I hope this shed the light on how innovations looks like in nuclear.
Yes, definitely. Thank you so much, Dr. Nouf. Dr. Thamraa, will you share with us also what innovation looks like in your field?
I will share the slide.
Yes, please go ahead.
Yeah, in my area, the solar energy, the energy of the sun is the original sources of the most of the energy found on the earth. Solar power is the energy from the sun that is converted into thermal or electrical energy. Solar energy is the cleanest and the most abundant renewable energy sources available. And we know that we can use the sunlight to convert it to the electricity using the photovoltaic system. With the photovoltaic system can convert the direct sunlight into electricity through the use of the solar cells. And the history of the efficiency of these solar cells was started from 1975 until now 2020. In the 1975, it was about 0.1 efficiency, very low efficiency. And with the years and with the conducting research and using different material and different technique, the efficiency was increased today to hit 40%. But the solar cells with the different structure and different materials, first was used the silicon, and we know that the silicon need more long process to produce and expensive and affected the environment. And then the next generation was the thin film technology. And the thin film technology, you're using dangerous material for the environment, like the cadmium arsenide, which is affected the environment. And the third generation, or the emerging BF, using the organic material, and this organic material friendly with the environment. But the problem with this organic material was the stability and the low efficiency. And through my visit postdoctoral in MIT, I worked in perovskite silicon tandem solar cells for hot and arid climate. And in this research, we are trying to improve the temperature stability for the perovskite solar cells, which is essential for the commercialization success for this technology. And the issue become especially for the solar cells operated in a hot and arid climate. And this work, we presented the perovskite solar cells structure with different structures and improve the temperature stability suitable to operate, as I said, in the climate like Saudi Arabia. Also, the meteorological data is used to establish the relevant operating condition for Saudi Arabia in this region. Also, we use different material trying to improve the stability of this solar cells. And this work was presented, I said, in the 2018 in MRS in Arizona. The innovation in solar cells in the future, I see 5 solar innovations that could change the future. First is the solar paint, second the solar windows, the solar cars, and the solar roads, and the solar water. Let us talk about every single one. The solar paint is a paint applied to the surface that will capture the energy from the sun and convert it into electricity. Solar paint may look like your typical paint, but it has a billion of pieces of light-sensitive material. This material that would transform the energy capture from the paint. For the solar windows are made of the solar panels that harvest the energy from the sun, converted to the electricity. And this panel refers to the type of windows, helping building owner achieve partial independence of the power grid. About the solar car, in the solar vehicle used for the land transport, solar cars usually run on only power from the sun. Also, some models will supplement the power using a battery or use solar panels to recharge a battery or run a system for a car that mainly use a battery power. About the solar roads, is a modular system of specially engineered solar panels that can be walked and driven upon. Panels contain LED light to create lines and signing without paint, and they contain heating elements to prevent snow and ice accumulation. And the panels have a microprocessor which make them intelligent. For the solar desalination, it is a technique to produce water with the low salt concentration from the sea water, or bringing brine using the solar energy. And there are 2 common methods for solar desalination. either using the direct heat from the sun or using electricity generated by solar cells to power a membrane process. And the Saudi Arabia plan to use a new solar technology to desalinate the seawater at Neom. And the solar dam plant will process drinking water more cheaply than converted to the plant. And I have a short video about the project which will be launched in Neom in Saudi Arabia for the solar water.
We don't have any sound, Dr. Thamraa, if you'd like to narrate for us a little bit.
Didn't see the video?
No, we see the video, but we don't have any sound. I don't know if you want to just mention what the video is describing.
Yeah, in this project, it is called the concentrated solar power, where it's the mirror, concave mirror, what set in a way that reflect the sunlight to the dome, and the dome take the heat from the sun, and in the dome there is a solution, usually a salt solution, which can store the heat from the sun. And this solution, we can use it to produce electricity or to use it to do for the water desalination. And this project is supposed to in the Neom, the city in Saudi Arabia.
Cool.
Yes, that's it. Do you want me to talk about my project? I don't know. I talked about my project in MIT.
No, thank you for this. And I think we have more questions, and maybe you can reference it again later. Before we move on to other topics, I wanted to check back. I think some people talked about their current research. Dr. Nouf, did you want to mention anything more about your current research, or what you wish people knew about your research particularly?
Yeah, so my research is all about accelerating innovation in nuclear structural materials, development and characterization as well. So I do this basically by combining ions and lasers, and this will allow me to explore and know more about the microstructural evolution and the degradation of material as we expose them to radiation environment. So the basic premise of my research is we want to sense indirectly and in a rapid way. I mean, indirectly means in non-destructive fashion and in a fast way as well, the evolution of the defects or the radiation damage that accumulate in the material as we expose them to radiation. So these defects or radiation damage can definitely lead to failure of nuclear system, such as the volumetric void swelling, which is the phenomena I'm studying. So in the void swelling, that means the materials, as we radiate them, they fill themselves with voids or buckets of air or vacuum. And that makes the material softens and weakens, and eventually these components can break. As you all know, nuclear radiation can cause huge changes to any material, going from human body tissues or solid, like hard alloys as well, that can be used in nuclear reactor. For example, this phenomena, that's as we irradiate materials tend to be weakened and soften. Material also can be destroyed by radiation damage, and my whole goal is to sense this damage as it is happening in a real-time scale. So these microscale voids also, as I said, can cause components to break, and this can be associated with radiation leakage, which can harm the environment and definitely the radiation marker as well. So that being said, and now knowing that these kinds of damage or defects are going to take place in material, because we always have radiation in a nuclear system. So it's very important and very critical to test any material for these kind of defects before we apply them to any nuclear system. The issue with going traditionally to investigate materials and test their susceptibility to radiation damage is it takes so long. So you typically have to do so many things, from preparing the specimen of the material, and it actually would have taken a year to accomplish just such a study on testing the material's susceptibility to radiation damage. And we can detect radiation damage in nuclear material quickly with this technique. It's a cutting-edge technique, actually, that allow us to accelerate innovation in nuclear structural material development and characterization as well. And we can make them accelerated to the speed of thought, where a new material can be fabricated, irradiated, or exposed to a nuclear reactor, then tested by using this photoacoustic technique that is based on combining ions and laser in mere hours on something like a benchtop equipment, which allow testing throughout dozens of materials for testing per week instead of doing this study per a year, which is less than 1% of the typical time if we do the old school radiation study. So it's all about making the radiation, the selection for the structural material in a more fast fashion technique as well.
That's exciting, and I imagine that it could also help prevent disasters in the future, right? If people understand quickly where the weak areas in a reactor are.
Exactly. If we apply this technique, and so my study is in an ex situ fashion. It can be easily converted to in situ fashion, where you measure these or you detect these damage as they are happening in real time. And this tells you when the material is close to be failed as well. Because, for example, if the structural material has 10% are voided or empty buckets of air or vacuum, that means it loses its ductility. There is 0% ductility, which means the material will break in any second. And that's what we call the incubation dose, which is the radiation dose that the material can handle before it totally breaks. And we don't want to be near that incubation dose. We want to know what is this incubation dose, which means what is the amount of radiation that material can handle, so we run way behind this dose to avoid any failure for our nuclear system.
That's great to hear, and looks like we lost Dr. Thamraa, but hopefully she'll be able to join us again. Dr. Malak, this question is for you. Has the COVID-19 pandemic influenced the way you think about your research or the future of your field of energy?
Yes. Okay. So I cannot imagine any person work or any field that has not been affected. So definitely, energy field is one of the fields and the sectors that tremendously have been affected with the COVID-19. We've seen and realized how during the lockdown the demand on energy fell down. How the decline, on the energy demand fell down, whether it is full lockdown or partial lockdown, is definitely affected. I think the idea of transitioning to more secure and resilient systems, energy system, has emerged strongly again with the COVID-19. We realize more than ever the importance of securing our energy sources. We don't want systems that can fail, and we don't want that systems that can increase the price while we are in need and there's crisis as well. So price increase within the time of crisis. Overall, the COVID-19 made it clear the importance to energy transition to clean energy. Clean energy will bring healthier environment. Healthier environments means better health, better for everyone, and means that even our health will be stronger, and we will be able to avoid such pandemics. Not totally avoid, but at least be stronger in facing these kind of health crises. So healthier human will help in avoiding such crises again. Of course, there's positive and negative impacts. Positively, that we can realize the importance of clean energy on this sector. Localization has also emerged as important. So it emerged as an important aspect in all the products. So depending on other areas, because of the lockdown, you want to continue the supply, and you don't want to be dependent on different areas that might affect it by the lockdown. In terms of the negative impact is, of course, clean energy, innovation in clean energy still requires, it's a still new sector, and it requires lots of funds. With the COVID-19 crisis and effects on the budgets, this will affect definitely the transition, will affect the projects, the ongoing projects or planned projects for the future. It might also affect the research and the fund overall. The government support for new venues might also affect it. Overall, I think this situation created a global understanding that we need to have comprehensive and collaborative approaches and responses to such situations to recover from the COVID-19 crisis. And clean energy is one way to power this recovery in a clean way.
That makes sense to me. Thank you.
I hope this answers part of your question.
No, that's great. Thank you. I think COVID is such a part of everything right now. It's nice to know how it relates in every situation. At this point, I'd like to invite, if there's any participants who have questions, please do put them in the question and answer feature. It says Q&A at the bottom of your screen. And I have lots more questions for our panelists, so I'll go on asking questions, but if you, as an audience member, have a specific question for any of our panelists, please put them in there and we will be glad to ask them. So I'm going to move on to a question about each of your time at MIT, and I know 2 of you are currently at MIT, 2 of you are looking back on your time at MIT. And what influenced you, and was there things about being at MIT that made you think about your research or innovation in a new way or a new creative way? So I'm going to go back to Dr. Fatimah. Dr. Fatimah, how about you? How is your time at MIT influencing the way you do research?
Okay, in fact, MIT is a such community where we can meet expert people who have the same passion in the energy research, so we can discuss further and exchange the environment, exchange the informations between us. And if we face a problem, we can discuss the difficulties that we might face, as we can meet a lot of people like professors, postdoc, and even students who are willing to work in this area. Furthermore, MIT can facilitate the research by providing us different type of instruments, and also they train us on these instruments so we can come independent user, and we can conduct our research without worrying on how can we characterize our materials and etc. Also, there is a Sloan School where we can improve our skills in different area like management and innovation area. So MIT is a such community where we can develop ourselves and improve our skills in different aspect or different area.
I'm glad you're experiencing MIT as such a supportive community, especially even during this pandemic. How about you, Dr. Malak? How was your time at MIT? How did it impact your research?
Oh, yeah. Okay. So I believe MIT is built in a way that the structure of MIT is actually creates innovativity along the hallways and the classrooms and the research groups. The system itself, it brings in innovation in everything that is happening in MIT. For me specifically, I benefited a lot from being in research groups. I was, during the time, I was in 2 different research groups with Professor John Leonhardt research group and Professor Steve Graves research groups. I also benefited a lot from also collaboration with the MIT Lincoln Lab, which happened through also through Professor Leonhardt, and I worked on a project with them for 1 year. This could not have happened if I was outside the doors of MIT. Also, the MIT is known for the research in energy with the MIT Energy Initiative and other initiatives that bring in the innovation to the minds and to the practices. Also, all the different seminars and events happening with all the discussions, the rich discussions with all the key researchers and key innovators in the field. Of course, this will stir in the innovation and help you think of everything in a different way. You might be working on something, someone else is working on the same thing, but you find that this is totally different ways of doing the different things. So just having a discussion is enough to bring in the ideas. I was at the first time I came into MIT and to Boston area, I was calling back my family and friends and saying, you believe it or not, finally you are in a place when you can be totally intellectual and talk all intellectual talks and nobody will judge you. you can do that finally. And not being told that you're talking just too much science or too much for us. So it's actually the right place for research.
Yes, it's definitely a place where you can talk all science all the time. We have a question here from an attendee, and I think it's a good question for you, Dr. Malak, and maybe Dr. Thamraa. What is your plan to implement what you learn at MIT to help empower Saudi women in the energy section in Saudi Arabia?
Yes, wonderful. I actually, I've been very, very active in the energy sector for women in Saudi Arabia. I've been carrying on events to introduce energy sector because we have probably, it's the lowest participation of women in Saudi Arabia in this sector. So I've been working on events, conferences to introduce energy sectors and all the job opportunities, bringing in pioneers in the energy sector from around the world to talk to youth and to young female, to introduce to them the opportunities in the energy sector. Annually, this event has been taking place. I also established Saudi Women Network for Clean Energy, and it's the website is up, and anybody can join the initiative and become part of the discussion. We share news. I introduce to them all the opportunities so that they can be involved as much as they can. Also in Rifat University, in my university, I involved my students in the engineering school in 2 different projects, actual real-world projects, to design and install and operate solar rooftops, 2 different rooftops. So it became for them as a practical experience that helped them. Now all of them, they have secure jobs when they graduated, because they actually touched and they actually learned firsthand how to deal with solar systems. So I think if we all work together, and my colleagues also here, Dr. Fatimah, Nouf, and all of us, then we will have a notable contribution of women in this sector.
That's very exciting. Thank you. And yes, please, Dr. Thamraa, go ahead. I know you also.
As Dr. Malak mentioned, also we encourage, in my university, we encourage our graduated student to join a project in solar cells or in renewable energy. Also, my university, the College of Science, the planning, inshallah, to open a master degree in renewable energy. Who the graduated from the chemical or physical department can join this program, master degree renewable energy. Also, I attend many conferences in renewable energy. I'm trying to find an opportunity for my student to be trained in different company or different sector in renewable energy, and make them have a knowledge of the solar of renewable energy, as Saudi Arabia now have a lot of projects in solar cells, and a lot of opportunity for Saudi Arabia to be moved from to be the first country in the world, inshallah, and renewable energy resources.
That's very exciting. Thank you. While I have you, would you like to talk about how your time at MIT influenced your research?
Being in MIT, it's a fertile environment where the creativity takes a root and grow and flourish, provide a wide variety of materials, access to a broad diversity of material, professors, and a lot of learning materials, and being in MIT, not just about the research, also you can improve your soft skills, conducting different courses, and the most of these courses, it's free, and we have a period in MIT in January. They have a lot of courses that's free. You can come and learn and conduct these courses. Yes, this environment make me learn from the expertise, trying to improve my research, and that's my time in MIT.
Thank you, Dr. Thamraa. And then we have a comment here from the audience thanking both of you for all of your efforts and saying it's very promising to see all your efforts to include other women in the field of energy. So thank you for all that you do. Dr. Nouf, how about you? You're still here at MIT these days. How is it impacting you and influencing the way you do research?
So I will echo all what the panelists said about MIT being the perfect environment for creativity and innovation and the hard science that can change the world and solve the big world challenges. Personally, my time at MIT is really making me believe more than ever that innovation is the answer for the brighter future of nuclear energy. Now I believe more than ever that this technology, despite its enemy and its challenges that it's facing, it's an important option for the world to meet future energy demands and needs without emitting the carbon dioxide. So now is the time to increase the efficiency and improve the safety features and to drop the cost also for nuclear power. And any research that will take us to these avenues is the right thing to do, either at MIT or at anywhere in the world. Innovation also is the fast track to make it happen faster. And I believe more than ever that it's really important to have an interdisciplinary studies that can solve the world challenges. That is the only way we can succeed, to have the interdisciplinary studies and to shed the light on complex world issues such as energy or health issues as well. And an example for my research, the cutting edge technique that I'm using was borrowed from optics, which is totally a different field. And it's been modified and accordingly have been used in the nuclear field for the first time ever. I just want to add that although like for me, my time and my research at MIT was interrupted by this pandemic, this coincidence also had just showed me how little I know and how narrow I was looking at the world's big challenges like energy, for example. I think this global pandemic also made the whole world realize the limits of their understanding and the boundaries of their knowledge as well. So from this experience, like being at MIT and being under the pandemic, I have learned valuable lessons on how the world should tackle and solve their problems. I have learned that no single hero can solve the world scale challenge alone. So we have to work together. Great world challenges like energy, as I said, need all of us to work together and to unite, as Dr. Malak said. The great mind and the superheroes out there need to unite their efforts and to work collaboratively and exchange on their knowledge and have the compassion to solve these big issues. We need to have the commitment to make this world a better place, no matter if we're working on energy or health or poverty or any other world problem, climate change, for example, which link other fields together. We need all these talents from different fields to make nuclear energy innovative, for example. We need the physicist, the chemist, the electrical engineer, the mechanical engineer, the material scientist, the computer scientist as well. Things that we never thought we need, now we need more than ever. We need to talk to each other, we need to listen from each other, and we need to think collaboratively on these topics and bring innovative techniques from other fields as well. So for example, back when everyone needed to work from home, I really thought deeply about how this can affect the safety of nuclear facilities, and how this is the really time to rely more heavily on passive design feature to prevent nuclear disaster instead of depending on real people being there doing the work. And depending on active engineered safety system and accurate interventions by human operators who sometimes will not be able to be there for any reason other than war or pandemic or crisis or whatever. So also cutting edge techniques that involves robotics and artificial intelligence could be borrowed from computer science to nuclear energy. This can help making the inspection and maintenance and the shutdown in the case of emergency be done more easily and in a passive way. So if you really want to accelerate innovation in this field, as I said, let's work all together. We don't know who can bring any idea from other fields and make it really work well for different fields.
I have a question here that matches perfectly with what you've been saying, Dr. Nouf. This question says, I'm a computer science PhD student and my research is in energy. My question is, how can AI be used to make intelligent energy management at smart cities from your point of view?
So if I understand very well the question, it means that she works in a computer field. So it was breaking.
Yeah, computer science, I think.
We need computer scientists all the time. Like we cannot risk building a reactor actually and put it there and see how things go. We usually start with simulation and see how things go. We introduce all the factors in a virtual way and study the whole and tackle the whole problem even before we put anything in our labs. So we much need this expertise in artificial intelligence or computer science or robotics as well to solve our big challenges. They save us time, material, and money as well, research money, as they will predict what will happen nicely and precisely most of the time.
Can I also answer the question?
Yes, please do.
Okay, so basically artificial intelligence and data science is really one of the main areas that can contribute to the energy field. I will explain to you or just give you an example from my point of view as I posted in the question, the way that I practice it. So there is something a view for the future of energy sector that's our energy called Internet of Energy. If you've heard of Internet of Things, there's Internet of Energy. This means that every appliance, every system that's plugged into the power sector or to the energy system, the biggest energy system, can be optimized in order to work in the right way so that it does not affect the whole system negatively, but rather positively. It can contribute to the holistic system and to the overall system by helping that system to work more efficiently. This can happen by introducing intelligent and smart components into all the appliances and all the electric vehicles, into any component that actually requires energy, so that we bring in a holistic system approach for more efficiency in the operations. I hope this will help you, just give you an idea how you can contribute from one narrow area, but there's many other areas that you can contribute to as computer sciences.
Yes, I'm fascinated to learn about the Internet of Energy as well. And audience member, if you have more follow-up questions, please go ahead and ask them. As we get near the end of the time, Dr. Thamraa, I don't know if I gave you a good chance to answer a question about your current research. Is there anything else you want to add about your current research?
Yeah, my current research in solar cells, trying to improve the efficiency of especially in the perovskite solar cells, trying to improve the efficiency and the stability. I do a collaboration with here in Saudi Arabia and in Germany and UK. And last summer I conducted research in 2019, conducted research in Trinity College of Dublin. On this research, I worked with the Professor Sarah McCormack, trying to creating materials that is sensitive for the sunlight and can be put it in the building as the window to capture the sunlight and compare it to the, as we know that the silicon solar cells, the wavelength for the capturing the light photon from 500 nanometer to the 1000 nanometer. With this material, if we put it in the top of the solar cells, silicon solar cells, the photon energy lower than 500 nanometer, it can be captured by this layer and compared to the area where the silicon solar cells can capture these lights and improve the efficiency of this type of silicon solar cells. And this layer can be put in the windows and in the building, trying to improve the performance of the silicon solar cells. And this my research it was in 2019 in the Trinity College of Dublin. And these days, especially in the COVID pandemic and the lockdown, I'm just working in the research. I didn't feel the side effect of pandemic lockdown. I just trying to work on different researches in solar cells and transistors and LED, any area related to my to improve my knowledge and to help my students in university in different areas of renewable energy. And as we mentioned, we are now in Prince Noura planning to open a master degree in renewable energy, and I am the manager of this program, trying to find a program which can the chemical student or a physics student or engineering can conduct this master degree, inshallah.
That's exciting. So you're sort of creating an interdisciplinary program around around energy.
Yes. Yes.
I have a question for you. I don't know exactly how it relates to your research, but you mentioned the solar paint, and how is the energy captured out of the paint? That seems amazing to me.
Yeah, the solar paint, there is in this paint, there is a species, small material, grains material that is sensitive for the light. And if we have a building and we paint this building with these materials and we connect it to the solar cells or other collector, this material can sensitive for the light, can capture the light from the sun and can convert it to the electricity. And this building can, cut half of the bill from using the electricity. Also, you maybe heard about the skin paint for the solar.
No.
This is the new innovation in solar cells. Yeah, you charge your phone with your arms. It's a new innovation area in the solar cells.
That's very cool. Seems a little weird, but it's very cool. Thank you for updating us and letting us know about your current research. It's very exciting. The last topic we wanted to cover before in these last 5 minutes is, what would you advise young people who are thinking about energy research to focus on? What's the area that you would say, go this direction? I guess because I can see you, Dr. Malak, I think you have an answer on your mind. So please go ahead with this question.
Okay, so I would say that this area is hugely open for any contribution. I think we've heard it today several times that all the disciplines are very much needed and welcome to contribute to research in energy. But it helps to organize our thinking. So basically, if you can group all the areas that you can provide your contribution in energy into 2 areas, engineering and economics and policy. And then for each technology that you are interested in or you would like to contribute to, you can address these 2 perspectives from different aspects. So for example, for the PV solar photovoltaic, then there is the PV cell fundamental research and the components that get into, as we've heard from Dr. Thamraa and from Dr. Fatimah, the components of these cells and how they are manufactured. There's curveless wafers. There's the how do we enhance the modules for the dust and to become resistant for the weather, especially in Saudi Arabia, we have dust issues. So dust repellent and hydrophobic coating. So also we can think of power and transmission modeling. System level approach of evaluation and modeling. The batteries, how do we optimize the number and the need for storage. The integration of data sciences and artificial intelligence. In terms of economics, we can ask many questions. How can we forecast the energy demand on a component or level or at the system level? How the capacity we can plan for an energy system or energy source overall, for example. Solar versus wind, how much we need, or at even a system level. So there is various level and there's various technologies and there's various perspectives that we can look at, and they're all open for research. including how do we finance the project, how the governments can price the energy, how do we help the government price the energy right for us. So all the disciplines, economics, energy, engineering, finance, law, mathematics are welcome to join and will help. The interdisciplinary approach will help in solving the problems.
It's an exciting field. We have just a couple minutes left. Fatimah, Nouf, or Thamraa, would you like to add anything to that?
I might comment on this.
Yes, please.
So for anyone who wants to start a new research, I want them to know the fundamental of that research, read a lot of it, know the applications, I mean the possible application of that research. And then from this point, try to change some parameters or properties to get to new applications. And my advice is to find something that can be renewable, sustainable, and could be more greener, I mean. Because the future of the energy, I mean, the trend is to have that the things that can't be end, like sustainable energy and renewable one. And that's it. So.
Well, thank you very much for that. And I want to thank each of you, Dr. Thamraa, Dr. Nouf, Dr. Fatimah, Dr. Malak, thank you so much for taking the time to be here today and be part of our webinar, and Dr. Kamal as well. And thank you to our audience. Thank you for taking the time to join us and learn more about all that's out there in the energy field. And I have one final slide to share. If you have more questions or want to get in touch with us, we have many different ways to get in touch with us. So thank you everybody for being here and being part of our webinar.
Thank you so much, Dorothy, and
Thank you so much.
all the panelists.
Thank you, everyone.
Thank
you
you,
so
Dorothy, so
much.
much.
It was good to see you all. Bye-bye.
Have a good day. Bye.
See you.
Bye-bye.